So, today's class we are going to see the next type of potential energy. So, as we derived formula and as well as many things we discussed in gravitational potential energy. So, keep it in mind, in yesterday's class, what we studied is the most important one. So, I hope you have remembered that. So, for that, if you want to find the mass of a small part, that is what, if I take the chain, am I right or wrong? So the mass of a particular part, if you want to take it, suppose total mass is m, means the particular part was to called as what? Dm, correct? So if you want to
Yes,
find
sir.
the mass of a dm, so you have to use a concept called as what? Center of mass. Understanding? Center of mass. So that is what you need to know. So as we know, for this object, the center of mass is not existed at here. So no center of mass, no like constant mass here for this one. So as it is, center of mass is not located for this chain, so that we have used a concept like integration concept to find the total. Am I right or wrong? And yesterday we have found that. So the total potential energy which is stored in the given chain, which is equals, how much is the answer we got it? 2mgr divided by pi. Am I right? So this is what total kinetic energy is. So total potential energy which has been stored. We got it. Am I right, guys? Everybody? Yes?
Yes, sir.
So now in today's class, we are going to see the next concept is another type of potential energy. As we know, potential energy is two types. So one is gravitational potential energy, GP, and the second one is elastic potential energy, EP. So with the elastic potential energy only, so we are going to see a type of potential energy which we used to call spring. So spring is an example of elastic material. Am I right or wrong, everybody? Yes, please. So that is what. So with the help of that, so we are going to see that what is a spring potential energy. So please all of you make it. Spring potential energy. So now, if you observe very carefully, you might be all knows the potential energy of a spring formula. Anybody can remember and tell me? So basically, you used to study. So potential energy is equals to what is the formula? Half into k into x square. So I will explain you what is x and everything. Okay. So k means spring constant. What is k? Everybody? K means? Yes, please. K means spring constant, and x means elongation of a spring from its initial point. So that is what it is, square of x square. So this is what we used to call as potential energy, or we can say which is equals to work done by the spring. Understanding, Rudreswar? Work done on spring, which is equals to the energy stored in the spring in the form of what? The work done on the spring is equals to, it will store in the form of what? Everybody. Potential energy. So which is only equals to half into k into x square. So this is what we used to call as the formula for spring potential energy. Spring, everybody, spring potential. So now, so we all knows that you can take either downwards, vertically or horizontally, whatever it is. So which is convenient to you. So there is a rigid surface. One side the spring has been attached. So that now if I attach some mass to them, so you can see after certain time, definitely there will be a change in length. The spring will start elongating and the length of the spring is definitely increases. Am I right or wrong, guys? So we all studied that after increasing certain length, if you notice it, this is the original length and the change in length is this one. So that is only we used to call as what, everybody? Change in length only we used to call as what? X. Understanding that? All of you? So the force exerted by this, keep it in mind everybody, the force exerted by the spring, which is equals to, which is directly proportional to elongation of a spring. That is what X. So or else you can take the spring like this. Yes, Mr. Greswa. So you might be studied the question, spring questions. So the spring is like this. Now the mass is attached to this. Now imagine that as it is now, initial position. So it has been traveled till this distance. That is what we used to call as x1. So further, if it is travel again stretched, elongation of spring will take place. Am I right or wrong, everybody? Please respond. So that is what. So let me take from the initial position, the distance is x2. So this is what it is. Okay. So now, what is the spring potential energy kinetic? What is the formula? Potential energy is equals to half into k into x square. So k means what, everybody? K means what? Spring's constant.
Spring constant.
The constant. So now x means the change in length of a spring. Change in length of a spring. So now that is what elastic potential energy and kinetic energy formula or spring potential energy. Now if you take here, I want to say one important point. So potential energy, as we all studied that, potential energy we cannot calculate. Potential energy of a body we cannot calculate, we cannot define. Only what we can define, guys, everybody? Yes, please. We people can define only one thing. What is that?
Change in potential.
Change in potential energy. So that is what all of you remember. Potential energy means like it is actually invisible form of energy. Invisible form of a energy. Okay. So it is imported. It is imported to the body or to the system. It's not that particular body, to the system. That energy stored in the form of what? Everybody. That invisible energy only will be stored. That energy is stored in the form of what, everybody? Stored in the form of potential energy. That is only called as potential energy. So invisible form of energy which is imported to the system. That energy is only modified into the potential energy. Do you understand, everybody? So that is only what we used to call as PE, potential energy. So what is the spring potential energy? We'll derive that formula also. Just remember that. What is the spring potential energy formula, everybody? Yes, U is equals to half into K into X square. K means spring constant. X means change in length of the spring. Now, so all of you observe. So let us write the question. So from the question, we'll derive the formulas. Okay, right. So find work. See, the work done by the body is equals to energy stored in the body. Will you all agree with me that statement? Mr. Kadir? Mr. Narayan? Yes? So that is what. So find work done by spring force. SPRING. Spring force in stretching. From x1 to x2 distance. x1 to everybody. x1 to x2 distance. So they are saying spring force. So spring force means it is a conservative or non-conservative. That is first target. Conservative or non-conservative? Everyone. Yes, please. Spring force is conservative or non-conservative? So it is a conservative force. So that. So we all knows that. Can you tell me what is the spring force? F is equals to formula. I already derived it. So spring force formula is equals to what? F is equals to minus of kx. So please learn if you don't know. So this force is a fixed force or variable force? Everybody. The force is a fixed force or variable force? All of you. Variable force. Do you all understanding, everybody? So now the force, spring force is equals to minus kx. What do you mean by minus kx? Anybody can tell? Means the displacement is in forward direction, means force is exerting what direction? Everyone.
Opposite.
Backward. Yeah. So there is a mass. So initially it has been moved x1 distance and then it has been moved to the new position. So that is what from the initial position I used to consider as a what? Everybody. X2 position. Okay. So now if you notice it, if a body moves x meters forward direction, means in the sense of the force exerted by it, which is acting what direction? Forward direction or backward direction? It is acting backward direction. That is the meaning of it. So spring force is equals to minus of kx. So the force is changes from where to where? Stretch from x1 to everybody. From x1 to x2. Understand? So now we have to find work done by the, calculate work done of the system or work done by the spring. So what is the formula? Work done is equals to, yes please. All of you respond. Work done is equals to, we all knows that. What is the formula? Limits x1 to x2, so which is equals to f dx. Am I right or wrong, everybody? Clear, everyone? Yes. So if I apply the integration, we all knows that x1 to x2. So f is equals to what? We all knows that f is equals to what? Conservative force. F is equals to minus kx into dx. So minus k is a what actually? Remains constant or not, all of you? Yes, please. So remains constant. So integration of I will take it minus k outside. So now, what are the limits, guys? x1 to x2 into x into dx. So what is the integration of x dx? Anybody can tell? Which is equals to what? X square by 2. Am I right or wrong? Yeah, speak loudly. So if Teriada, please learn. X power n is equals to, what is the formula? X power
N plus 1 by n
divided
plus
by n plus 1. So please learn it. So what is that, everybody? Now minus k is constant, so the formula will turns into x square by 2 whole square. Am I right, guys? Everybody? Yes, please respond, all of you. Yeah. So now this 2 I will bring it this side, so it will turns into minus k by 2 into x square. So minus k by 2, what is the limits, Ra? Limits varies from where to where? From x1 to x2. Am I right or wrong? Please respond. So
yes,
that
sir.
is equals to x square into x1 into x1 to x2. So now that's all. We can replace it. So what is happening, everybody? So it will turns into minus k by 2. It will turns into x square means I can write it
X2 square minus x1.
x2 whole x2 square and here minus x1 square. Am I right or wrong?
Yes, sir.
Yes, that's what. Now, here also minus is there, here also minus is there. So work done by the spring, which is equals to what will happen? Minus k by 2 x square, x2 square, plus minus into minus plus. Am I right or wrong, everybody? So that k by 2 x1 square. Is it right, guys? Everybody, will you all agree with me? Yes. So that is what. So work done by the spring is equals to. So spring is a conservative or non-conservative force. Everybody. Spring is the conservative. Okay. So what is the work done by the spring? Work done by the spring is equals to minus, you take it half front. So that I'll modify this one as minus kx square plus plus 1 by 2 kx1 square. Am I right, guys? Will you all agree with me? All of you, please. So that is what.
Yes, sir.
So that is the work done. Work done by the elongation of spring. Everybody clear? Please speak. Any doubt? Please let me know. All of you understand now? Yes. So now, so this is what work done. But we all know that work done is equals to this much. But what is conservative force? The forces. Potential energy, what is remains constant or changes are? Everybody. Change in potential only is equals to work done. Am I right, guys? Please respond. So U2 minus U1 is equals to, so work done, you tell me, what is the formula? U2 minus change in potential energy equals to minus of work done. Am I right, guys? Work done,
Yes.
what forces? Work done by what forces? C means. Work done by
Conservative.
C, Ra.
Conservative
C,
force.
C means what? What forces there? Conservative force.
Conservative force.
That is which is equals to how much? Minus of this one, so that it will turns into what? Minus of this one. So it will turns into minus of this. So minus of half into k x2 square minus, sorry, plus 1
Sir,
by
plus
2 k1 x square. So now this minus will be go inside, so that it will turns into what, everybody? Yes, please. Change in potential.
minus k by 2 x2 square.
Yeah, minus 1 by, see, minus it will become plus, plus will become minus. Am I right, Rudreswar?
Yes, sir.
Yeah. So just it will become plus, it will become minus. Minus 1 by 2 kx square. Okay. Now this one.
Minus.
Yeah. So actually before also it is minus. Am I right? I forgot it. This is also minus. So minus into minus, it will turns into what? Plus. And
Yes,
here
sir.
minus into plus, it will turns into minus 1 by 2 k1 x square. Am I right, guys? K x1 square. All of you understand? Please respond. So this is only
sir.
is equals to what we used to call change in
Potential.
potential energy. So have you all understand how to find it, everybody? Please respond. Everyone?
Yes.
This is what? So minus of work done. Change in potential is equals to minus of work done. So this is what we people will used to get. So everybody, hope you all people got the same thing. Am I right, everyone? Clear? Understand? So now, so from this I will make a note. So all of you observe very carefully, very important. If the spring length is not varies, spring has a natural length. So if the spring has something, then it's a fixed length. Then what about the work done by the spring? What is the work done by the spring, everybody? Yes, please. 0. And potential energy is also equals to 0. Keep in mind, if the spring has natural length means what, guys? Normal. Whatever you buy, the same length will be for continuing. So that is what we used to say, normal length. No diameter increases, no diameter decreases and all. So spring has normal length. If it has a normal length, then F is equals to what? Force exerted by a body. Force exerted on the body, which is equals to how much?
0.
0. And
0.
if force is 0, then automatically some other thing is 0. What is that? Yes, please. If the applied force is 0, then
Work done.
work
also 0.
also 0. That's what. So now, let from this concept. So as we studied, change in potential energy equals to half into kx2 square minus half into kx1 square. Clear, completed, Pradosh? Anything down? Let x1 is equals to 0. What is x1? Everybody, let x1 is equals to, yes, 0. So that initial velocity, sorry, initial potential energy also will become 0 or something else. Anybody? As the x1 is equals to 0. So potential energy of the 0. Let I am saying that's what. So now if you observe very carefully, so can you tell me what is the, for example, so let me take now, there is a spring, load has been attached. Please listen very carefully. It has been traveled till U1, okay, or V1, and after that it has been traveled till V2. Okay, so this is what. So we all knows that potential energy is equals to what is the formula? Half into, yes, please, K into x square power 2. So this is, sorry, x2 power 2. Am I right, guys? Everybody, please respond. All of you? No response. Okay, so that is what. So now let us assumption. You assume that, you make it that initial velocity is 0 at natural length. At what, everybody? Yes, please. Natural length. So keep it in mind. Okay. So if you make that like, then always the potential energy is equals to, what is the formula? Everybody, half into K into x square. Clear, everyone? Please respond. That is what. So always now the point which I say, remember. So spring, two things we can do. Suppose Mr. Rudreswar don't want to see it in normal position. So he can undergoes what, everybody? He undergoes the extension of spring. Am I right or wrong? So maybe original
Yes,
length.
sir.
So now due to the force, what is happening? Well, that is also what forces it is. They are,
Conservative.
yeah. So if you assume that natural length, if it has a natural length, then if you see that, always x1 is equals to what? Assumption I made it. X1 is equals to what? 0. And that is also will become 0. So now we have written that all of you observe change in potential energy. So U2 minus U1, which is equals to half into K into x square. So let me take x square, x2 square minus half into K into, what is that, everybody? X1 square. So as it is x1 is equals to 0, then this whole term will become what? Speak loudly, everybody.
0.
0. So then what else remaining with this one? Change in potential is equals to half into k x2 square. Am I right? That's all is the equation. Am I right or wrong? All of you.
Yes, sir.
U2 minus U1 is equals to half into k2 kx2 square. So this is what, if you see, all of you. So this is the only thing we used to call change in potential energy. Only let me take as a u. Then here what will happen? K into x square, not x2 square like that. So what is the potential energy formula, everybody? Yes, please. Elastic potential energy formula. What is the elastic potential energy formula? Please speak. Or spring potential energy. What is the spring potential energy formula? Half K into, yes, please. Half K into x square. Now, the most important and interesting point about it, you remember, this one is always positive. What is that, everybody? Always positive. Sir, why, sir? Let me see that. Either it is, now this is called as what? Extension or compression? All of you. So this is extension, and I can make it as a what, everybody? Compression also. Okay. So either if I do the spring, either extension or compression, remains this value is always what? Everybody can tell.
Positive.
Yes, it is
Positive.
always it is positive. Which one it is? First one. Let me take universal, that is what, potential energy due to the gravitation and potential energy due to E. So because of these two, so can be what? Everybody can be negative or positive? Yes,
Negative.
negative. Understanding? So the potential energy due to the gravity, potential energy due to the, what is E means? What is that? I forgot it. Elastic. Yeah, elastic potential energy. So this both always can be negative. But next, potential energy in a spring. So always what? Keep it in mind. Always it is, everybody,
Positive.
positive. Keep it in mind. This is most important. So U is always what? Everybody. U is always, yes, please, positive. Understanding? So if we assume U is equals to 0, so when it will assumption, anybody can tell me when the initial, the X will become 0. Anybody? Assumption. Anyway, that I already told you here. See that when it will becoming 0, spring has what length?
Natural.
Natural length.
Natural.
U is equals to also 0. Means in the sense of, I assumed here assumption U is equals to 0 at what length? Everybody. U is
Normal length.
Normal.
yes, that
Natural.
is normal. So assumption I'm making, all of you observe, if U is equals to 0, at what length, everybody? At, yes, please.
Natural.
So
Normal
then,
length.
yes, then potential is equals to what is the formula will come? Ex2 square. Am I right, everybody? Clear?
Yes,
So
sir.
always keep in mind this entire U is equals to always positive. Understanding? Either the spring is compressed or the spring is stretched or elongated. Means stretched means length is increasing or decreasing? Everybody, length is increasing. Compression means length is decreasing or increasing? Everybody,
Decrease.
decrease.
Decreasing.
Both the cases, potential energy stored in the body is always what? Everybody, is always
Positive.
positive. But if you observe the potential energy due to gravity, potential energy due to electrostatic, that's whatever. So that is maybe 0. But if you notice it, sorry, can be negative. But the potential energy which is caused by, what is this? Yes,
Spring.
yeah, spring force. The potential energy caused by spring force is always what?
Positive.
Positive. Okay. So that is what you have to remember. Any doubt in this, you can ask. I hope you understand. Everybody? Yes. So that is what it is. Clear?
Yeah.
Yeah. So what is the formula? Potential energy equals,
Yes, sir.
spring potential energy equals to half into K into X square. That's all. So now, with this remembrance, let us solve. All of you once again, I'll repeat. Change in potential energy is equals to what? Everybody? Minus of work done. Am I right or wrong? Please speak.
Yes, sir.
By remembering this, we will solve.
Yes.
Now, the question is, please make it. So there is a question like, observe, am I anybody having doubt? You can ask me, please. So mass M, by just touching the spring, it has been traveled 1 meter. How much meter, everybody? It has been traveled 1 meter.
1 meter.
So after certain time, the boy reached to the some other point, so which is actually 2 meters away from the initial. And the spring constant K, which is equals to, let me take 1000 newtons per meter. What is the spring constant K value? Everybody? Let it is 100, let me take. So why 1000 means bigger? Let me take it as how much? 100. Okay, 100. Then
100.
question is, find the work done. Find the work done by spring force in stretching from x equals to 1 to x equals to 2. So can anybody suggest me what is the ways to solve? I'll give the clue. F is equals to minus of fx. Okay. So now what way? We have a limits also. So to find it, what formula we can use? Anybody? The work done by the spring force in stretching from x1 to x2. So that there is a difference. You can see that from x1 to x2 it is moving. So we already knows that F is equals to what is the formula? F is equals to minus of kx. Yes. Now tell me what concept you have to use it to find that total work done by the spring. Anybody? Yes, please. So I can use there is a limit so that what I can do the work
Sir,
done by the
actually
total
can take
spring force
minus
WS
by 2 x2
WD
square
work
plus
done by work done by spring force is equals to, can I say integration of limits is equals to 1 to 2 minus of kx dx. Am I right, guys? Yes, please.
sir.
So now
Yes,
minus
sir.
k is constant, so I will put it outside and remaining limits 1 to 2 x dx. So we all knows that x dx integration of
X square by 2.
x square by 2. Formula if you want, x square n plus 1 by n plus 1. Okay, all of you understand? Please speak, guys.
Yes, sir.
So now, if I substitute it, then minus limits 1 to 2 x square by 2 dx. So that minus k by 2 integration of x square 1 to 2 dx. So which will turns into, so we all know, sorry, x dx. X dx only we used to call it as already I have written. So that it is x square by 2. Am I right, guys? Everybody?
Yes, sir.
So that is now we want it. You can see if you keep on going substituting the limits. So 1 to
Sir,
2.
dx will not
Yes.
do.
Dx I forgot it. Sorry, brothers. So here already it is over. Am I right? So integration of that.
Yes, sir.
Yes, yes. The limits is actually the x square by 2 itself it will over. Correct? S
Yes,
square by 2 limits I forgot it. What is the limit? 1 to 2. So
1 to 2.
what will happen? 2. Already 2 is gone, correct?
2 square minus 1
Yeah,
square.
2 I will take it. So 2 square minus 1 square, which is equals to how much of this one? Which is equals to 4
3.
1, which is equals to minus 3k by 2. Am I right or wrong?
Yes, sir.
Sir,
So which is equals to minus 3 into k value, how much they have given? 100 divided by 2,
100.
which is equals to how many joules? Work done by everybody.
150. Minus 150.
Minus 1.
Work done by spring force is equals to minus 150 joules. Means minus indicating what? Force is exerting opposite direction.
Opposite direction.
Understanding? M means all of your mass. Remember, displacement will be, displacement symbol is S. Mass symbol is what? Everybody, M. So displacement will be downward direction. So the word force, the Fx is acting what direction? All of you. Yes, opposite direction. Understand? So that is what? Upward means it is upward and downwards. Basically the diagram you see that. So now as it is, if you want to calculate the work done by the spring force, so this is what it is, we'll calculate. Then the work done by the spring, it is equals to, that is what, how much is the answer we got it? Everybody, work done by the spring force, which is equals to minus 150 joules. Means
150.
indicating, minus indicating what? It is moving in the opposite direction. Ellame puriyuma? Yes, please respond.
Yes.
So what is the
Yes,
work
sir.
done? Now, do you think only this method is there to find this many big steps we have to do it, Mr. Rudreswar? There is a method we can find it very easily. Anybody think over it? Mr. Narayan, Mr. Monish, girls, please. What do people think? Is it the only way to solve this question? Is there another way? It's not there. We know that. So work done by conservative force. Then what is who is the conservative force here? The conservative only force we used to call it as what? Everybody. Yes, please.
Spring force.
Spring force. So keep it in mind that. Okay. So it is a spring force. So now, so what is it? Everybody tell me. So what will happen? There is another way. Just now I told you. Work done by the conservative forces, which is equals to something. Anybody? Which is equals to change in potential energy. Am I right or wrong?
Delta.
Yes. So that's
Yes,
what.
sir.
So now what will happen? Change in potential energy. We have got the formula. half into K2 square, sorry, K, what is the formula? I forgot it. Everybody, Kx square, x2 square, minus half into K1 x1 square, which is equals to what is that then? Everybody should speak. So which is equals to what? Conservation by spring force. The spring force only we used to call as what? Everybody? The spring force we used to call as what? All of you. It is example of
Conservative.
conservative force. That's what. So I'll replace it. Minus of SF, conservative force. The formula is half into K2 x2 square minus half into K1 x1 K1 x1 square, which is equals to minus of work done by what force? Work done by everybody, spring force. Okay, so that is, so if it is a natural length, if there is no elongation of a spring, if it is a natural length, then do you expect, is there anything change in that x? Anybody? All of you? There at a natural length, what will happen? Please respond, everybody. The potential energy is stored in the body at a natural length.
Half K.
Yes. Which is x is equals to 0 at natural length, Rudeshwa. As x equals to 0,
Sir.
total potential energy is what? Yes, please.
0.
Okay, that is what it is. Now, so this is one question. There is another question. Everybody solve. Try to solve it. Make it quick, everyone, so that you can make it. So observe very carefully. So we all knows that if you leave it undisturbed, so definitely there is a change in the length of the spring. Am I right or wrong, guys? That is,
Sir, equilibrium.
yeah, equilibrium. It will attain the equilibrium. So imagine this is the natural length. What is this one, everybody? It is the natural length. Always the weight of the object will act in the what direction? Downward direction.
Downward.
And definitely there is a upward force. That is what we used to call as. What is that force we used to say?
Spring force.
Yeah,
Spring force.
The spring force is opposite direction. That is what
Tension.
force. Kx. Am I right or wrong? And the spring constant is K. And what is the spring force, everybody? Yes, please. Spring force is equal to
Kx.
Kx. Why I am not writing here minus? Anybody can tell? Because it is already opposite to the what? Yes, please. It is
Direction of
downward direction and the spring force is acting upward direction. So that it is both are opposite or not? Please respond, everybody.
Yes, sir.
Yes, that is what. Now, this spring I left it for undisturbed. I left it for undisturbed for a certain time. So now I notice it. So there is a elongation, understanding of the spring. So let me take here not. So the spring itself is stretched. And finally that is the second length of a things. Now here, what is the change in length of the spring? Anybody can tell from, actually this is actual length, natural length. Natural length means what is the potential energy, everybody?
0.
0. Now the body has been responded and extended up to here. Then what is this? Anybody can tell? The change in length. That is what we can assume as a what? Yes.
X.
Yes. And now, as this body is also weight is acting downward direction. Now you can tell me, and the spring constant will act what direction? Spring force. Everybody, which will act in opposite direction. So
Upward.
that minus XR, just KXR. Kx. K is indicating opposite direction. So it will acquire the what actually after slowly elongation. What will happen? The position we used to call as what? Everybody.
Equilibrium.
So if it is equilibrium position, observe very carefully. If I draw FBD of this one, so down is mg, up is kx. So now can you tell me from that, can I say like normal? So normal is acting upward direction and which is acting, the weight of the body is acting downward direction. So from that, can I say normal is equals to mass into acceleration due to gravity? We have done or not? Everybody? Yes?
Yes, sir.
Same way, instead of here, normal, it is kx. So kx is equals to, so what will happen? Mg.
Mg.
So from that, x is equals to, because we want to find only that x. Am I right or wrong? So x is equals to what is the answer? Everybody. Mg divided by, yes, mg divided by k. So now the question is, what is the u of, understanding, u of mass due to spring? Again, I will repeat the question. What is the potential energy of a mass due to the spring, due to the elongation of spring. Either it is a compression or elongation, both. Let me take it as a compression. Now, what is the potential energy formula? We all knows that. We have solved it also. So, what is the potential energy formula? U is equals to half into kx square.
Kx square.
So now tell me that, everybody. So half into, so k value is k only. So that x value. So what is the x value? We got it. Yes, please.
mg by
Yeah, x value is equals to what? Mg by k whole square. Am I right, guys? Please respond. So which will turn
Yes, sir.
half into, this will turn mg whole square divided by, yes, please, k square. So can I write this one as half into k into mg? How I can write, guys? Speak loudly. M square g square divided by, if you observe,
Sir,
very
k cancel.
kk into kk, one kk will get cancelled with this. So remaining it is there, correct? So half into,
Sir.
so what will happen? This one, m square g square divided by k square. Clear? All of you understand?
Sir, k.
by k.
Not k. Yeah, sorry. It's not k square, it is a k. So that is what? Half into m square into g square into k. So that is only they're asking. What is the potential energy when it is? So what is the potential energy? Everybody? Half into m square g square by what? Everybody?
K.
Okay. So that's what you have to remember. Please make it. Any doubt? Anyone can ask. Do you all understand now? What is the formula for spring elastic energy? Spring elastic